This is a fully 3D printed guitar that I am currently building, and it has more electronics in it than your local Best Buy. How many hours do you think that I have in this? It's way more than that. I am not kidding. I've got over a year's worth of work into this project, and it's not slowing down anytime soon. For those of you that have stumbled in here for the first time, what I'm doing here is building a fully 3D printed guitar. Yes, that includes the neck, and it's got a ton of electronics stuffed into the body with the intention of having it fully covered in programmable LEDs. Also, Odin willing, making this guitar be able to tune itself with motors. I have a technical background. I'm in technology, but I'm not an engineer, unless you count software engineer, but I don't. Also, I've never built a guitar before. This is the first I have ever even attempted. The odds are stacked against me, but here I am, still going at it. So by the end of the last video, I took this prototype about as far as I could take it. And it's about that time that I realized that I really should have had this just manufactured by a PCB fabricator. And that's just fancy speak for a company that can build the circuit boards for you. There are gonna be times when something like this is a lot more appropriate for the project, but considering the complexity, let's just say that I wish I would have made the jump a lot sooner. So how do we do that, you ask? Well, let's take a look. I'll save the deep dive for a more focused video on electronics, so I'll keep it kind of high level here. This is called a PCB schematic, and this is important because it allows you to actually visualize how everything is routed. Basically, I just group everything by its purpose. So I want to make sure that I've got all the power delivery stuff and put that all in one area here. Voltage changes that need to happen in the second stage, the group 2. Group 3, switch the guitar on and off. 4, temperature. 5, the fan that can kick on and off as needed. Group 6, why isn't there a group 6? I don't know. Group 7, this is basically where all the information is transferred back and forth between all the components so they can talk to each other, but this does include the microcontroller, which is basically the brain of the system. Group 8 houses the motor drivers. These are little ICs or little chips that can handle 2 motors on each. So if I've got 6 strings that I need to tune, I need 3 driver chips. Group 9 is an amp circuit. In order to be able to read the signal and tune the guitar, I have to have the signal high enough for the microcontroller to be able to read it. So you have to boost that signal with something called an op amp. And lastly, the indicators group is a series of LEDs to know what is happening on the board at any given time. Now, this might look a little intimidating, but I'm not going to go into all of the different little squigglies and how all these components work together and everything. This is more just to show you what it looks like to have one of these boards laid out on screen, and then I'll show you the 3D version where you can see how it will actually get produced. You might notice that that's a weird shape, but I needed to get as much real estate out of it as possible, so I designed around the electronics cavity directly on the CAD file. You can see some of those groups that we were talking about earlier. The huge power section over here, that handles a lot of different tasks, managing power and pushing things in and out. We've got the guitar switcher here, the amp right here, we've got the motor drivers, the microcontroller, and once it's all put together, it looks a little something like this. Now, this is just a loose 3D rendering, and it doesn't show every single component, but it gives you a good idea of what it's gonna look like. And yes, I've got some graphics on the back just for the fun of it, because you can do that kind of stuff. So now that I've got this full design, how do I actually get this thing produced? Well, I was already halfway through designing this when a company called JLC PCB reached out and asking if they could sponsor a video. So here we are. JLC makes it easy to get a super quick turnaround on custom PCB fabrication. You can design your PCB in any popular design tool and upload those files to get an instant quote. They have a tool called JLC DFM that you can use to sanity check your design, and I used this tool to catch a few things that I missed, which saved me a ton of headache. So once you're ready, upload to the quote page, choose your options, and check out. It really is that easy. Oh, also, they keep you updated on every step of the process, which is super entertaining to follow. My boards arrived within a week, and the unboxing experience did not disappoint. The quality and the accuracy was just hard to comprehend, and seeing my design come to life was incredible. And by the way, that's just one of their many services like high quality 3D printing, CNC machining, and seriously, way more than I can even list. So if you're working on your own projects and you want pro level manufacturing without that pro cost, check out JLC PCB. The link is in the description. I spent a couple days just admiring these boards. At least that's what I like to tell myself. The reality is that they are very intimidating. There are, not exaggerating, hundreds of traces and components to test. To start off, I just wanted to make sure that there was nothing crisscrossed, so when I put some voltage into this, there was no magic smoke. That part seemed to be fine, so the next step was to add some components. I sprung for the template option when I got the PCB, which is basically a big sheet of metal that's got all these little holes punched out in exactly where the solder should go, which makes it super easy to lay everything down. What I didn't think about was the fact that I had to test every one of these areas of the board board, and I wouldn't be laying down all of this stuff all at the same time. So instead of using the template and soldering everything all at once, I decided to focus on just soldering sections of the board at a time so I could test everything carefully. The first area I'm focusing on is power, and that's where I'm going to be bringing in some voltage that is a little too high, so I need to drop it so I don't fry the components on the board. I kind of haphazardly dropped in these components, and then I just wired it up, and this happened.
Oh, it works! Holy shit. Okay, so you probably have more confidence in me than I have in myself right now. When I test the 5-volt rail, 5 volts. I've had no formal training. I did not expect any of this at all to work the first time. Now I only have about 200 more components to test, but it works! Yay!
I'm no stranger to the highs and lows of DIY projects, but let me tell you, that success carried me a long way. In fact, I had all sorts of wins in these early stages. Don't get too cozy though, he said to himself. There is a storm brewing ahead, as we will soon see. But for now, let's bask in these early carefree stages where the LED indicators worked almost exactly as I expected, aside from me just making some stupid mistakes. Oh, and I also had to jump back to the power side because I needed to drop some voltage even further for some other really sensitive components. This is really common in complex devices. You start with a higher voltage and then you just reduce it in stages for all those different components. And just to call the power section done, I added the chip that's needed to negotiate the right voltage from the power source. I installed the guitar switch components next, which is what turns the signal of the guitar on and off on demand. I'm also installing the preamp or the op amp there. There's no way to test any of this, so at this point I'm just hoping that everything's going to work when I plug it in. Some of this I'm learning as I go. I've done plenty of soldering, but I've never soldered these small chips onto a PCB, and you can definitely tell that from the first few that I did. Speaking of which, I completely borked the first 3 motor drivers. They were a mess. I was only able to save one of them. Nothing here is like super expensive, but you keep buying these components over and over and it really does add up. Since I can't really test any of these more complicated circuits without something to control them, I had to just bite the bullet and install the header for the microcontroller and then all of the header, the pins for all of the external devices that send signals and get power from the board. I mean, at this point, it's looking pretty cool. I don't know that it's necessarily doing what it's supposed to, because at this point, the bugs started to make themselves known, starting with the temperature sensor, which somehow I misrouted. Luckily, I was able to tap into another pad that was close by to fix it, and that wasn't really a big deal, but the next bug was in the USB power. That port that I'm fiddling with is actually feeding into something called a USB PD system. What that means is that devices can be plugged into a special USB port that effectively allow them to pull as much current or voltage as they need. It gets a little more technical than that, but that's the basic idea. Really, all the magic happens in that little chip that I'm testing, and I should have been getting 12 volts, but I was stuck with 5, so clearly I burned it out and needed to replace it. But you can't make an omelet without breaking some chickens. What? Finally, I got to the point where I felt comfortable enough plugging in the microcontroller. This is the most nerve-wracking part of any project I've ever done, plugging a microcontroller, an expensive microcontroller, into a board that you designed, hoping that all the little teeny tiny signals going to it don't exceed the maximum voltage for each one of those pins. Fuck, raising my blood pressure just thinking about it. And this is why somehow I think I had 5 volts running to a 3.3 volt pin, and just like that, it was dead. 35. No, $40 now a piece because of inflation. Because of that mistake, I'm taking a lot more precautions, and clearly that won't happen again, he said with misplaced confidence. Okay, I've got a working board. I need to make it do something. This is the first official test of the TNC on the PCB. I'm gonna try to make this fan spin, and oh wait, it started and then stopped. Full disclosure, I was actually not using the same transistor that is marked here. I swapped it out for one that's a little more appropriate. Okay, it is done. Would you look at that? I've got a temperature sensor here right there. I'm gonna go ahead and put my finger on this to just kind of see if I can warm it up a little bit. Looks like it's going up. So now I can use that to determine whether or not I need to turn the fan on. Pretty freaking cool. In its most basic form, the PCB works now, but I need to be able to power it with the onboard USB. It's showing up as a USB device. Let's see if I can push code to it. Yes. I mean, really, how cool is that? Oh no. We're good? Oh, I hope I didn't break it.
Oh, no, we're good.
The control board is not something that I plan on testing extensively right now, but I do need some buttons to work with, so I went ahead and created a wire harness. We made it to assembly, and this is nothing short of a roller coaster. It's easy to build up a bunch of confidence when you've got everything on the bench, but as soon as you start stuffing everything inside the guitar cavity, that's when all these weird variables start to surface. Things that you obviously should have thought about, like whether or not it fits, and then the more complicated stuff like what's going to happen when all these wires get crunched together. You stack that on top of the fact that I am still building a guitar, and that's something that I sometimes forget. Safe to say that at this stage, the overwhelm really kicked in. But I am nothing if not relentless, so I just keep on keeping on. And speaking of, this is about where I realized that if I was going to put all this together, the guitar should probably play. So I had to make a decision on the fretboard. There are screws on the fretboard to hold it down, but that was more aesthetic than anything. And the goal was eventually to actually glue it down. But there are wires and LEDs running all throughout that neck. I still have to figure out whether or not I'm gonna have to do more shielding, or even if the shielding acts as an antenna or something. I don't know. But before I tackle all of that, I just need to make sure that everything's still working after I put it all together. And of course it doesn't, because we wouldn't want this to be too easy. There are a couple spots on the fretboard and on the headstock that are behaving a little oddly. None of it's a big deal. It's just something to work out. It just takes a little bit of poking around, and hopefully I don't fry anything in the process. And it seems I got lucky this time. Like I said, it's a hands up in the air, sick to your stomach while you're having a blast roller coaster.
That's weird.
I think I'm gonna let that one slide for now though, because the next part is a huge milestone. I haven't worked on the fretboard or anything yet, so I can't really play the guitar, but it is put together, it's functional technically, and I've got the electronics sort of functional, so now I need to put them together and see what happens. Even though the noise floor is a little higher than a normal guitar right now, considering the fact that I'm running all of those electronics and it's got a cheap pickup in it, I'll take it. But the neck LEDs did not go so smooth. Objectively, that is kind of a cool sound. I might have to sample it. Unfortunately, you don't want your guitar screaming like that all the time. Before doing anything rash, I did a little bit of research and found out that these little pixel lights tend to generate a lot of EMI. So when you've got dozens of them surrounding a pickup, it's like a chorus. I haven't busted out the oscilloscope yet, but I have tried every basic technique that there is for managing noise. None of them helped except for one thing, and I don't know how I feel about it. If I tee off from the input source of the power, whether that be the battery or a USB input or whatever it is, and then run that to an external buck converter down to 5 volts so I can run 5 volts out to the LEDs, I can then actively see a difference in the EMI when I move that buck converter around on the guitar, which means I can probably combine shielding and then moving that away from the electronics cavity to hopefully get some control of this, because that's just not something that I can live with. It's not all gloom and doom though. I mean, I've made a ton of progress and nothing is crashed and burned yet. If you haven't already, check out the other videos in the series. Please take a moment to like the video. That helps out a ton. Questions or comments, or you just want to shoot the breeze, I'd love to chat with you in the comments below. I've already got a jump start on the next video, so you'll see another update pretty soon. Take care.